For this example, let's go and define a struct. I'll call this one player stats. Then I'll also do an AI stats one. Let's say we have some basic text-based adventure game. We have our player, and what we want to keep track of is its health, armor, mana, XP, and its level. For the AI, let's say all we care about is, let's say, health. And let's say we have some weapon damage variable as well. I'll just go and add that to the player stats one as well. Alright, so a few things to note. Firstly, you can go and separate these out using a comma, the comma operator, but typically they are written like this in a struct and in a class as well. Another thing to note is you can use the same identifier, so the variable names for your members for different structs. So in player stats and AI stats, I have health and weapon damage in both of those, and there won't be a conflict with that. That's fine to use it in this way. I'll just go and save that. To differentiate between variables, so in your function such as main and your member variables such as in here, let's say health, what you can do is you can prefix that with an M, so lowercase m, and then it's easy to see, okay, this is a member of something. Now that's not very common, so I'm just going to undo that. And let's say we do player 1 for the player. Of course, this is going to be global now, so you can go and declare that in main, but for this demonstration, I'm just going to do it here. Then let's do a few declarations or instances of AI for our game as well. Okay, so we have those variables set up. So I have those set up and we can use them now. Another example here, you can think of a struct, so a struct variable as a single entity basically, right? Even though it is complex, so it has multiple members, so it is a composite type. But if you think of it as one compound variable, or comparing it to something like an integer or a float, those can be assigned to each other. So let's say you have integer x and integer y set to different values. You can set integer x to whatever is stored in integer y by simply doing x is equal to y using the assignment operator. Now with structs you can do something similar, because each instance of that struct has the same data structure basically, right? Now the rat's weapon damage should be equal to 50. And that is what we get. So this may seem a bit weird, but let's say rat and alien were integer variables, then this line is not that strange, right? But if you think of a struct as a single, complex type, then that makes it easier, because once again, each instance of that struct is now going to have the same members, so you can just copy them like in this way. So you can do it in this way instead of doing something like this. So for something like this, it's okay because we only have two variables. But in the player stats, for example, you can see we have many variables, right? Now, of course, if you only want to assign a single variable, only the weapon damage, since the health is the same anyway, then you can just do that single variable. Otherwise, if you want to assign every member, then just do the variable name, so that instance name, and set that to the other instance using the assignment operator as we've done it before. Like that, right? In this next section, I want to demonstrate some of the types that come with Unreal Engine, such as FVector, FRotator, and so on. So this is just a simple project called the Apple Picker game. You are supposed to have some sort of a basket down here, and then you have this tree that will move to the left and to the right. Sometimes it will change direction randomly. It will drop or spawn apples to its left or right, also randomly, just to add some randomness and variation to the gameplay. And you are supposed to try and catch those apples with this basket. And of course you don't want to lose apples, but I just have the basic game loop. I don't have scoring set up for this. Alright, I'll just go and play that. So I have my basket down here. I can move that to the left and to the right. We have the apple tree at the top. This is just programmer art, of course, using spheres and cubes and cylinders and so on. And I can now go and try and catch those apples. Try not to lose any. Every once in a while that tree changes direction randomly. It moves quite slowly because this is just the first level. So this is a project in the Unreal Engine C++ series where we'll apply some of what we've learned in the study unit prior to this Apple Picker project. So how do we move things around and so on. And then in this project, the goal is to learn input, again get that basket moving to the left and to the right, and a few other things such as the camera manager. So next I'm going to show you some of the types in Unreal Engine, so a vector and f rotator, which are also structs. Now before I do that, I would like to mention that you will see quite a few things that we have not talked about yet, such as template functions, a couple of weird operators, and I'm not going to explain all of the code. I just want to demonstrate some of what you can expect going forward, going into game development, where structs are used. Alright, so don't try and understand everything that's going on here. So here's a quick example in the spawn apple function, which will be called every second. We have something called an f vector and an f rotator. I declare those as spawn location, spawn rotation, because I want to use these to spawn apples every second at a specific location and at a specific rotation. I'll just go and right click on that and I'll peek definition on this. So here you should have struct a vector. This is one of the types in Unreal Engine basically. And then you have float x, float y, float z. So in 3D we work with x, y, and z, right? For left, right, up and down, forwards and backwards. And you have a bunch of things that we are not overly concerned with right now. Similarly, I'll just close out of that. Similarly, the f rotator, peak definition on that. You have something called pitch, yaw, and roll. You can see around x-axis is roll, and then yaw, which is like turning your head left and right, that's around the z-axis, and then pitch is around the y-axis. And so as you can see, there are data containers for the location and rotation of something, and so you work with vectors quite a lot in Unreal Engine, and of course in game development in general, you'll be working with vectors quite often. I'll just go to the vector definition once more, scroll down quite a bit. We'll talk about constructors a bit later, but for right now, I'll just pick definition on that, just to get scroll down a bit faster. And you have a bunch of definitions here. So for example, you can do dot product. They're overloading a few operators as well. So as you can see, really complicated stuff that they are doing here with a vector, which once again is a struct. So I'm just showing these examples to you so that you can see it is not just used as a data container. It is typically used for that, but as you can see here, you have a lot of functions to modify the data that is stored within an instance of that struct. So in this case, an a vector or an f rotator for things such as mathematics, again the dot product, cross product, and so on. So I want to spawn to the left or to the right of the apple tree. So I just do this here, which will return a float between 0 and 1. I do spawn location.y just to add some offset so that once again I can go and spawn apples to the left or to the right of the apple tree. And then I do the spawning. This is really complicated. I think maybe for you at this point, it involves templates and pointers and so on. We'll talk about that a bit later. But basically you can see I'm using the spawn location and the spawn rotation. Now of course I've modified the spawn location. This is a temporary spawn location, a variable I've modified here, depending on this outcome, right? And then I pass it in here to go and spawn those apples, and this once again will be called every second. This is more a real-world example of something that you'll do maybe in Unreal Engine or some other game engine if you're interested in game development. Struct is very useful for a data container, but then you can also have functions that go along with that to modify or manipulate those members or the data that is stored within that struct. You also have an f vector 2D. Go and modify this one here, big definition on that, and you'll see we have a vector 2D. Because it's 2D, we have float x and float y. So let's say for up and down, left and right. So we don't have a forwards and backwards, for example. In this case, it's just 2D, right? But then you still have a bunch of functions that you can use to go and manipulate the data that is stored in your instance. So just a quick demonstration in Unreal Engine. For this demonstration, let's do a vector 2D for our characters in our game as well. So we have float x and float y. And this is another important thing. I mentioned that you can treat these custom types similar to how you can treat the regular types, so integers and so on. And what this means is you can include those in other structures as well. So this means we can include a vector 2D in our player stats and in our AI stats, for example. Okay, so how would we initialize this now? So in the AI stats, for example, we have 125 and then the next member. Now what is this next member? Well, this next member is a list. It's a vector 2D. So we use the list notation. It's going to take two values, but I'm going to only add a 1. So 125 and then 5 for the vector 2D. From that inner struct, that inner instance of type vector 2D, we can now go and access those members, so x and y. Yeah, actually I'm just gonna delete that, build and run, and you'll see what you get. Ret location x will be 5 and y will be 0. Okay, you don't get any warnings, you don't get any errors. Remember with the array we talked about the initialization, this list style initialization, and that whatever you don't specify, it's going to add zeros. That's why we get a 5 and a 0, because I haven't specified y. If I do something for y, something obvious, 999, then you'll see we get that printed out for y. For alien, we did not even specify a value for the location variable. So this means we should get 0. Now just to be sure, what you can do is you can specify an empty list instead of doing nothing. I prefer to do that, just to make sure that those members do actually get defined to 0. So that about wraps it up for this video. I just wanted to demonstrate a few more things to you here. Go and practice with arrays, so add an array in a struct and use the dot operator to access that member. Assign it, again using the list initialization method, which is going to be similar to how I showed you just a second ago to initialize a struct variable type that is within another struct variable type. So go and practice that, get comfortable with structs, because the classes section is really going to build on top of what we've learned here. Right, I'll see you in the next video.